Okay, so you're standing on the platform, right? You're staring at that screen, next train, 2 minutes. And you trust it. But have you ever actually stopped and thought, how does it know that? Well, it's not magic, but the technology behind it has gone from super simple sensors to this incredibly smart predictive system that's basically a virtual copy of reality. So let's pull back the curtain and see how that sign knows exactly where your train is.
All right, this whole journey to knowing your train's arrival down to the second, it all starts in the simplest way you can imagine, with a really basic question and a simple piece of text sitting right there on the tracks.
Look, before we get all high-tech and complicated, the system just has to answer one fundamental question. Is there a train right here at this exact spot or not? That's it. It's a simple yes or no.
And yeah, this little flowchart, it lays out the basic logic perfectly. The first systems use stuff like ultrasonic sensors. The sensor just sends out a sound wave. If a train's there, the wave bounces back, and boom, the system knows to do something, like operate a safety barrier. Simple, super effective, and it's the very first building block of the whole smart system. But, knowing if a train is at one specific spot, that's not really enough, is it? To run a modern metro system, you have to know where every train is all the time. And this is where we level up from a simple yes or no to a constant conversation. And the tech that pulls this off, it's called Communication-Based Train Control, or CBTC for short. This is basically the nervous system of a modern railway. It's all about using radio waves to create this constant, real-time connection between the train and the people in the control room. So you can really just think of it like this. The train and the control center are having a non-stop digital chat. The train is constantly pinging its exact location and speed, and the control center is sending back instructions. It's this continuous two-way street of information that lets them manage the whole network so precisely.
And what can the Operations Control Center, the OCC, do with this chat? Pretty much everything. They can remotely wake up a train in the depot, make it run its own safety checks, control the doors, tell it exactly when to go and when to stop, and of course, track its location with pinpoint accuracy. It's total remote control.
Okay, so let's recap. We've gone from knowing if a train is here to knowing exactly where it is at all times. But the next revolution, wow, it's even bigger. We're now getting to a point where the system doesn't just track the train, it knows how the train is feeling.
This table just lays it out so clearly, right? Simple sensors tell us if a train is here. CBTC tells us where the train is. But artificial intelligence, AI gives us insight into the actual health and condition of the train. This is the huge leap from just tracking to actually understanding.
Yeah, AI is basically the brain for the entire metro system. It's constantly crunching these massive streams of data from thousands of sensors, not just to see what's happening right now, but to predict what's about to happen. This is the game changer, shifting from fixing things after they break to preventing them from ever breaking in the first place.
And look, this isn't some far-off future stuff. It's happening right now. In places like Delhi, AI is predicting track failures. In Mumbai, they're using lasers and machine vision to constantly check train wheels for any wear and tear. AI even scans video feeds for things on the tracks and helps manage crowds to keep everyone safe and moving smoothly.
Being able to see problems coming before they happen is, as the experts say, a major leap in metro system management. And what that really means for you and me is just fewer delays, safer trips, and a system you can actually count on.
So we've got sensors, we've got constant communication, we've got an AI brain. What's the final piece of the puzzle? Creating a complete, living, breathing, virtual copy of the entire metro system. Welcome to the world of the digital twin.
A digital twin is, well, it's exactly what it sounds like. It's a dynamic digital copy of every single physical thing on the railway, every train, every bit of track, every station. And it's not just a static 3D model. It's alive, constantly updated with real-time data from the real world.
So how do you even build something like this? Well, it kind of breaks down into 3 big steps. First, you use Building Information Modeling, or BIM, to create these incredibly detailed 3D models of everything. Second, you hook up countless sensors, the Internet of Things, or IoT, to feed live data into that model. And finally, you use a Geographic Information System, or GIS, to place that entire digital world in its exact real-world location. You're literally putting a digital brain over the physical world.
And the result is, honestly, it's mind-blowing. It's like the most realistic video game simulation you've ever seen, except every single thing happening on the screen is also happening in the real world at the exact same time. Every decision, Every stress on a bridge, every person on a platform is mirrored perfectly.
I mean, can you imagine the power this gives the people running the show? You can test out a new train schedule in the virtual world before you ever try it for real. You can watch the structural health of a tunnel in real time. You can perfectly manage crowds during a big concert. Systems like the Delhi-Meerut RTS corridor are already using this to plan and operate with a level of precision that was just impossible before.
Okay, so that is a ton of incredible tech. Sensors, AI, a full virtual replica. But let's bring it back down to Earth. Why does any of this matter to you and me, just trying to get from A to B?
Well, the contrast is pretty staggering. We're moving from an old system that was reactive and manual to a new one that's predictive and automated. Instead of data being stuck in different places, it's all integrated, which just leads to a way more efficient and reliable network for all of us.
And this really works. We're not just guessing here. Just look at the Shanghai Metro. By using AI to predict maintenance needs, they cut their unexpected equipment failures by over 30%. 30%. That's a massive difference you can actually feel as a passenger. And that's really what it all boils down to, isn't it? Every single layer of this technology, from that first simple sensor to the crazy complex digital twin, it's all designed to do one thing: make your journey safer, faster, and more predictable. So the next time you see that arrival sign, you'll know there's this incredible digital orchestra working behind the scenes to make sure it's right.
Which kind of leaves us with this one big final question. If we can build a completely virtual, self-aware transit system that practically runs itself, what other parts of our cities could we build a digital twin for? What does a truly smart city even look like? The possibilities, well, they're really just getting started.